Zero carbon construction. Did you know the construction industry accounts for about 40% of the total carbon emissions? Let's have a look at the causes of these emissions. Capital carbon is emissions arising from the construction and production stages. It includes all direct emissions from the construction processes as well as indirect emissions stemming from the production of materials and the components. These activity categories have together been estimated to account for approximately 87% of the total emissions in construction of the buildings and approximately 80% of total emissions from infrastructure construction. The construction sector accounts for a considerable share of global emissions. The exact amount of emissions is difficult to calculate due to lack of reliable and cohesive data from all the countries. In 2018, manufacturing of building materials accounted for about 11% of all CO2 emissions globally. Estimates have shown that the construction of buildings and infrastructure accounts for around 7 GTCO2e or 20% of the global carbon emissions. In addition to the capital carbon, fossil fuel use for transporting material, equipment, and machinery to, from, and within construction sites is the main emission source during the construction phase. Emissions arising from construction are dominated by 5 activity categories: concrete manufacturing, steel manufacturing, asphalt manufacturing, heavy transports, and construction machinery. These activity categories have been estimated to account for approximately 87% of total emissions from construction of buildings and approximately 80% of the total emissions from the infrastructure construction. As you can see, around 4.1 billion tons of cement was used in 2018. China alone accounted for 52% of the demand. The production of cement is responsible for about 5 to 8% of global carbon emissions. Similarly, the steel used in the construction sector accounts for about 3.5 to 5% of global carbon emissions. In 2019, 919 million tons of crude steel was used in the construction sector. What is zero carbon construction? We define net zero carbon construction as the zero net capital carbon emissions associated with construction assets, allowing for investment in carbon offsets to compensate for the remaining emissions that cannot be removed entirely from the construction phase. There are a lot of benefits to zero carbon construction. Zero carbon buildings can improve building health by curbing fossil fuel combustion that worsens the air quality, especially for children, the elderly, and the marginalized communities. Better building codes and building performance standards can reduce reliance on fossil fuels, enhance ventilation, and make buildings less leaky, which would improve the indoor air quality and decrease the energy use and reduce the emissions. Although this seems easy, but there are a lot of challenges faced. The major challenges faced while building a net zero carbon building are the lack of comprehensive standard system considering different factors, lack of a carbon emission calculation method for the design phase, and no real-time optimization model aiming at carbon reduction. Combating these challenges has become easier due to these solutions. To reach substantially lower capital carbon emissions in the construction projects, these are the few key solutions. Develop policies, client engagement, and requirements for capital carbon reduction. Plan cities, buildings, and infrastructure to avoid carbon emissions. Design buildings and infrastructure to enhance modularity, flexibility, multifunctionality, and minimize carbon footprint. Use fossil-free transports and machinery during construction. Compensate for remaining carbon emissions. Implementing the abatement measures in the first 4 steps will lead to substantially reduced capital carbon emissions. It has been estimated that the emissions could be reduced up to 50% in the construction projects by using technologies that are already available in the market. Let's have a look at the examples of zero carbon buildings. The Unisphere in Maryland, USA. The Unisphere stands in the middle of the city in downtown Silver Spring as a sterling example of technologies embodied, making it a fully sustainable net zero energy construction. The National Renewable Energy Laboratory in Colorado, USA. This entire campus is a living precedent of sustainability, and the people at NREL are transforming energy through augmentation, research, commercialization, and dissemination of renewable and energy efficient advancements. La Jolla Commons, San Diego, California. It is considered to be one of the largest net zero buildings in the US and is fed by biogas to reduce the energy costs. Indira Paryavaran Bhavan, Ministry of Environment and Forest, New Delhi, India. India's first net zero building constructed in 2014, Indira Paryavaran Bhavan sets a deep rooted example for the conventionally designed commercial built forms. The structure design encompasses a unification of active and passive strategies that help reducing energy demands. Avasara Academy, Lavale, Pune, India. This structure obtained the identification of a net zero energy structure because of avant garde design, interventions, and use of high efficient technologies that reduce the energy dissipation by 85%. I would like to conclude by saying that the solutions that exist today are not sufficient to decarbonize the construction sector. Several innovations are needed. We see that there are innovation needs in mainly four areas: alternative construction materials, new industrial processes, zero emission construction sites, and zero emission transport systems. To help decarbonize the construction machinery at the construction sites, we could switch to electric construction sites. To decarbonize the heavy transports needed to supply construction sites with materials, we could use electrified roads or hydrogen and fuel cells. To decarbonize the manufacturing of construction materials, we could switch to hydrogen-based steel making, electrified cement production, and full-scale carbon capture and storage. The new materials which could replace the traditional carbon-intense materials like steel, cement, and asphalt are sea-grown constructions, bio-based asphalt, and graphene. Thank you.